Welcome back to the show. This week, I want to start with a shift in the AI industry that has been quietly building for months and this week undeniably crossed over. For a really long time, dealing with artificial intelligence basically felt like consulting an incredibly fast, slightly unpredictable oracle, a magic 8-ball on steroids. You typed a prompt into a text box, waited a second, and it handed you an answer. It was a transaction, a very impressive transaction, sure, but a fundamentally static one. You were the driver. The model calculated the probability of the next word replied, and the interaction ended until you asked the next question. If you've been looking at the news over the past week and feeling like that dynamic is fracturing, like AI is suddenly moving from just answering your questions to actually doing things autonomously, you are absolutely right. We are officially entering what the industry is calling the agentic era. It is a massive shift, no longer a theoretical roadmap on a whiteboard in Silicon Valley. It is happening right now, actively reshaping both software and hardware across the board. But, and this is a huge but, that transition is proving to be almost painfully expensive. It's triggering a massive hardware and infrastructure crunch that the industry is dramatically calling Ramageddon. And the day-to-day reality of deploying these autonomous agents is turning out to be much messier than the glossy marketing videos would have you believe. So for the next 20 minutes, we're taking a stack of the biggest news stories from the past 7 days up to July 8th, 2026. We're going to separate the genuine strategic shifts from the Silicon Valley hype, sifting through model releases, hardware panic, and economic fallout, so you understand exactly where this technology and the broader economy are actually heading next. Let's get into it. To grasp this shift toward agents, we have to start at the foundational level, the models themselves. And the biggest indicator this week came from OpenAI, which just published the system card for their new generation of voice models, GPT-Live 1 and GPT-Live 1 Mini. The standout detail is a technical capability they call full duplex. Instead of the old walkie-talkie style where you speak, pause, wait for the model to record your audio, translate it to text, generate a response, and speak it back. These new models are processing and generating audio natively and concurrently. They listen and respond continuously. That changes the entire architecture of the interaction. The model can follow pauses, handle interruptions, change pace, and decide in the moment whether to chime in or just keep listening without waiting for a defined turn to end. Now you might be thinking, Siri has been in my kitchen for a decade, so aside from interrupting it when it gets a pasta timer wrong, how does full duplex actually change the work I can accomplish? It goes much deeper than politeness or latency. When you use a traditional voice assistant, you are constantly adjusting your behavior to accommodate the machine's limitations. You wait for the beep. You enunciate. You don't interrupt. That cognitive load is entirely on you. Full duplex eliminates that friction by shifting the cognitive load to the model. The AI stops acting like a search engine and starts acting like a real collaborator you can steer dynamically while it works. That is step one for deep agentic workflows, because it lets you manage the agent the way you would manage a human colleague without breaking its operational loop. An OpenAI system card details new voice-native safety evaluations for things like emotional reliance and illicit behavior. The safety guardrails are evolving from simple text filters into essentially behavioral psychology, because the AI is simulating a relationship, not just providing data. Meanwhile, on the coding side, xAI launched Grok 4.5. They're billing it as their smartest model for coding, agentic tasks, and knowledge work. What caught my eye is that they trained it alongside the coding platform Cursor. That shows a very specific strategic focus on getting the AI to execute complex, multi-step engineering work directly in the environment where code actually gets written, rather than chatting about code in a browser window. Two different labs, same convergence. OpenAI is engineering for seamless, continuous, real-time audio interaction. xAI is prioritizing deep, multi-step reasoning and execution inside developer environments. Real-time adaptability and autonomous execution. Those are the mandatory building blocks for an agentic future. While the models themselves are incredibly capable in a lab environment, getting them to execute tasks autonomously in the messy enterprise world is proving to be a canyon of a gap. We saw this vividly this week. Mark Zuckerberg admitted in a recent internal town hall that Meta's AI agents haven't progressed nearly as quickly as executives modeled. He noted their recent corporate restructuring around AI hasn't borne fruit yet, though he's hoping to see improvements in the next 3 to 6 months. That is a surprising admission from a company that has bet aggressively on the technology. And it isn't just Meta. Microsoft is actively substituting models in Office 365, Word, Excel, the tools you probably use daily. They are quietly replacing the expensive OpenAI and Anthropic models with their own much cheaper in-house My models, specifically to bring down exorbitant AI costs. That is a glaring signal to the broader market. Microsoft is OpenAI's biggest backer. If even they are concluding that frontier models are too expensive for everyday enterprise tasks, the current deployment strategy is fundamentally flawed. Even the cyber criminals are learning that agents are hard to build. Security researchers at Sysdig analyzed a piece of malware called Jade Puffer, which was heavily hyped on the dark web as, quote, the first AI ransomware. It was supposed to be a fully autonomous agent that broke into servers, moved laterally through networks, and wrote its own customized ransom notes. Sysdig confirmed that despite all the marketing, the agent constantly got stuck and still required a human overseer to manually execute the operation. That perfectly illustrates the 80-20 rule of software development amplified for the AI era. Getting an AI to do 80% of a task looks like pure magic, but getting it to reliably do the final 20% without hallucinating, getting stuck in a loop, or breaking down is excruciatingly difficult. So are we basically paying premium salaries for an intern we have to micromanage? Right now, yes. Here's what this means for you. If Microsoft is abandoning frontier models for basic tasks because of the costs and agents still need human babysitters, the business model for enterprise agents isn't broken. It's undergoing a painful, completely necessary correction. The initial Silicon Valley assumption was that you throw massive trillion-parameter frontier models at every single problem. Need to draft a quick email? Trillion-parameter model. Summarize a spreadsheet? Trillion-parameter model. That's running incredibly complex matrix math just to write a headline. Renting supercomputers for everyday tasks is financially unsustainable. The future of agents isn't one giant omniscient brain doing everything. It's a swarm of smaller, highly efficient, specialized agents coordinating with each other and only calling on the expensive frontier models when deep, complex reasoning is absolutely required. But cheaper software models are really just a band-aid. The real reason these agents are so expensive to run isn't just software bloat. It's a physical bottleneck. We literally do not have the right hardware to run them at scale. Welcome to Ramageddon. The tech world is facing a severe shortage of memory chips, RAM, driven entirely by the demands of AI data centers. To capitalize on this crunch, the South Korean memory maker SK Hynix is launching a massive US IPO that could raise up to $28 billion. Sit with that for a second. $28 billion just for one memory maker to expand capacity. Meanwhile, to address the compute side of the equation, NVIDIA just launched the Vera CPU. They were very explicit in their marketing. This is a processor designed specifically for the agentic AI era, to speed up agent loops. What's fascinating here is that we are watching the hardware paradigm shift in real time. For the past few years, the entire industry has been obsessed with GPUs, graphics processing units, NVIDIA's bread and butter. GPUs became the engines of the AI boom because they have thousands of cores that are incredible at the parallel processing required to train massive models. They crunch the math. But as we move from training to the agentic era, the bottleneck has completely shifted. Think about it like a commercial kitchen. GPUs are the massive commercial ovens used to bake the cake. That's the training phase, but RAM is the countertop space where you actually prep and stage the ingredients. Once the model is trained, you have to actually run it. That's inferencing. And if you envision a future where there are billions of autonomous agents constantly running loops, taking an action, checking the result, retrieving data, verifying it against instructions, they don't need a bigger oven. They need more counter space. Massive amounts of high-speed memory to store the continuous context of all those concurrent tasks without dropping data. You can't have a billion agents cooking at the same time if you have no counter space to prep the ingredients, hence Ramageddon. And on top of the memory, you need specialized CPUs like NVIDIA's Vera that are incredibly fast at single-threaded performance to manage the logic and routing of those agent loops, rather than just the parallel math of a GPU. The infrastructure of the internet is basically being rebuilt from the ground up for persistent autonomous workloads. Here's what this means for you. If you're an investor, the picks and shovels play in AI is shifting from pure GPU exposure toward memory manufacturers, high-speed interconnect, and specialized CPUs built for agent loops. That is where the next decade of compounding hardware returns is going to happen. But it's not just about the silicon, it's about how developers are engineering the scaffolding around the models to escape this bottleneck. NVIDIA announced this week that their Nemotron 3 Ultra model, when paired with LangChain's Deep Agents harness, achieved top-tier performance at a 10 times lower inference cost. And critically, they didn't retrain the model to make it smarter, they just engineered the environment around it. LangChain CEO Harrison Chase pointed out something vital. You build better agents by improving the system around the model. If you give a cheaper open source model better memory management, sharper tool use, and strict evaluation frameworks, you can squeeze frontier-level performance out of it. Clever software architecture can temporarily alleviate crushing hardware costs. The desperation to escape the hardware bottleneck is palpable. There's a single-source report from TechCrunch, citing the information that Anthropic is quietly discussing building custom AI chips with Samsung. I want to flag this clearly. A single source claim requires broader verification before you build anything around it. But whether that specific deal pans out or not, it highlights the sheer panic across the industry to find a way out of NVIDIA's grip and the limits of the current memory supply chain. Here's what this means for you. If you're evaluating AI tooling or investing in this space, the frontier isn't just which lab has the smartest model, it's which lab has the smartest stack, the coordination layer, the tool integration, the evaluation frameworks. That's where the actual production performance gets earned. This massive reallocation of capital toward new infrastructure and specialized agent development is creating brutal economic shockwaves. We're looking at a bizarre dual reality economy right now. On one hand, historic wealth creation for AI-native startups. Anthropic reportedly crossed a staggering $47 billion annual revenue run rate. Just to clarify what run rate means, that's projecting current monthly revenue out over a year to show growth velocity, not confirmed annual revenue. Mercor, an AI startup that hires domain experts to train models, hit a $2 billion run rate just months after crossing their first billion. The velocity of that revenue growth is virtually unprecedented in enterprise software. It took legacy SaaS companies decades to reach those figures. And then you look at the traditional tech workforce, and the reality is harsh. Major tech layoffs are rolling through the industry, and companies are explicitly citing AI realignment as the cause. Microsoft cut 4,800 jobs, Cisco cut 4,000 jobs, Cloudflare cut 1,100 jobs. Capital is being aggressively diverted from legacy operations to fund the exact hardware and infrastructure demands we just discussed. Here's where it gets really interesting, the pattern of who is losing their jobs. Cloudflare CEO Matthew Prince stated very directly that the vast majority of the 1,100 jobs they cut were what he called measurers, middle management, revenue recognition, internal auditing. It seems AI is fundamentally eliminating the middlemen of the corporate world. If you think about what middle management actually does in a functional sense, they route information. A middle manager takes high-level strategy from executives, breaks it down into actionable tasks, monitors progress across departments, aggregates the results, and reports back up the chain. They measure and they route, which is exactly what an autonomous software agent is designed to do. So the companies minting billions in revenue, Anthropic and the platform builders, are providing the exact tools that make human measures obsolete. Why pay a team of analysts and managers to audit expense reports, track project milestones, and chase down status updates when a swarm of agents can do it in real time for a fraction of the cost? We aren't just seeing temporary job losses, we are seeing a structural flattening of the corporate hierarchy. Here's what this means for you. If your role primarily involves aggregating information across teams and reporting status upward, the traditional measurer role, that is the most exposed function in the corporate world right now. The compounding roles are the ones that require judgment, strategic decision-making, direct execution, or genuine specialized expertise. If you're inside a measurer role today, the window to reposition is now, while your organization still has budget for internal transitions. But the agentic era isn't staying confined to computer screens and spreadsheets. This week proved that the architecture is rapidly breaking out into the physical world. The software agents are getting physical bodies and learning to navigate space. Many are calling this the ChatGPT moment for robotics. A startup called General Intuition just raised $320 million at a $2.3 billion valuation. Their thesis is fascinating. They believe large language models aren't enough for true physical intelligence because they don't fundamentally understand space, time, or physics. So they are training physical robots using data from video games. The logic is actually sound. To build what's called a world model, an AI that understands physics like gravity, momentum, and spatial relations rather than just language semantics, you need massive amounts of training data. Video games provide infinite physics-based simulations where an AI agent can fail 1,000,000 times at navigating a room or picking up a heavy object without breaking 1,000,000 expensive real-world robot arms. And the big players are making physical AI accessible to everyone. NVIDIA and Hugging Face just announced a massive collaboration to democratize robotics. They're bringing NVIDIA's Isaac GR0T 1.7 foundation model, designed for humanoid robots, and their Cosmos 3 world model into Lee Robot, an open source library for the robotics community. This is a watershed moment. What Hugging Face and NVIDIA are doing with Lee Robot is exactly what open source models like Meta's Llama did for text generation. Lee Robot provides standardized software wrappers for motor control and vision. By putting advanced visual language, action models, and simulation tools into a standardized open source hub, they are entirely removing the software barrier to entry. A teenager in a garage can now download a world-class AI model, plug it into an off-the-shelf robotic arm, and have it autonomously sort objects. We are about to see an absolute explosion of developers building, training, and deploying autonomous physical agents. And physical agents are increasingly moving beyond the lab. This week saw reporting on autonomous ground vehicles being deployed at scale in high-stakes, real-world environments. Think industrial hazards, disaster response, and logistics operations in terrain where traditional human navigation is either impossible or extremely dangerous. The jump from a digital agent summarizing an email to a physical agent navigating a complex, unpredictable, high-consequence physical space is happening much faster than our regulatory or ethical frameworks can adapt. So let me summarize the landscape we've mapped out. The shift from chatbots that answer questions to autonomous agents that execute tasks is officially underway. We see it in the new full duplex voice models from OpenAI and the autonomous coding environment from xAI. But this transition is driving a massive hardware crunch, Ramageddon, because running persistent agent loops requires entirely new memory architectures and specialized silicon. That friction is causing a massive economic realignment. Trillions of dollars are being created in AI infrastructure, while traditional corporate structures are being rapidly flattened as software agents take over the coordination and measuring roles historically held by middle management. And finally, this intelligence is stepping out of the servers and into the physical world, driven by open-source robotics libraries and video game simulation data, with autonomous physical agents beginning to operate in real-world high-stakes environments. The agentic era is here, but it requires a very healthy dose of skepticism to see past the Silicon Valley hype and understand the actual hardware costs and deployment limitations involved. Which leaves us with the critical question worth genuinely sitting with. As open-source platforms make it easier for anyone to build functional autonomous robots, and as the computational cost of running AI reasoning eventually drops, we are going to see agents everywhere. When an autonomous agent fails, whether it's a digital agent hallucinating and draining a corporate bank account, or a physical robot making a critical error while navigating a public street, who is ultimately going to be held responsible? It's the ultimate operator problem. If you hire a human intern who makes a massive error, you are still the manager responsible for their mistakes. But what happens when the intern is an open source algorithm moving at the speed of light, built on data no one fully understands, deployed inside a physical body no one specifically manufactured? That is a completely new vector of legal, financial, and operational risk, and nobody, not the boards, not the insurance industry, not the courts, has a satisfying answer yet. Watch it, position for it, and if you're an operator, the next 12 months are going to reward the companies that figure out agent governance before they figure out agent deployment. Thanks for going down this week with me. Pay attention to who's holding the keys. I'll see you on the next